Okay, see, these are a few things from Chapter 6. And we learned in Chapter 6 that the mean difference, you could just subtract the means. We also, I think we calculated the difference in Chapter 6 and found out the shortcut would be just to subtract the means. Instead of doing all the work of the combination of them subtracted, it worked out to the same thing. But the tricky part with Chapter 6 was that you can't just subtract the standard deviations. And this is dealing with variance. And it was always the sum of the two variances equaled the variance of the difference between the two sets. And then you'd have to square root both sides to be able to get what the standard deviation is. And for center, this is also something that we worked on for the same type of idea. I believe in your formula sheet, on your formula sheet, it says that the proportion is just the mean value. So if you were to just subtract the means, you would basically just subtract the proportions. For our spread, or our standard deviation, we've talked about this variance, and you need to use this formula for your standard deviation, and that's also on your formula sheet. And notice, so I'm putting it in place, and it's got to be the variance, so it's got to be the squared value of these two. And the squared value of a square root means just the regular amount. This squared and this square root would eliminate. So then you're going to be left with something like this. Oops, minus 1 plus, and this is going to be your variance. But in order to get this variance to be the standard deviation, you've got to square root this side. So if you square root this side, to get the standard deviation, you also have to square root the other side. And this formula is on this bottom corner down here on your sheet, and that's a picture of your formula sheet so that you're more comfortable with it. It's right on your formula sheet. You don't have to memorize it. To tell that something's approximately normal shape, it's got to fit these conditions. And this problem has to fit not only these conditions, but we're going to have two sets. That's got to fit. So for the first example, we've got school 1, 70% did homework last night, and we're doing a sample of 100. 50% did homework last night from 200, a sample of 200 in school 2, and we know that this is the difference of our proportions. So our shape, the only way we can say it's normal or approximately normal is to do some of these calculations. And let's back up for a second and list all these. What is N1 and what is P1? What is N2 and what is P2? N1 is the sample size of the first school, which is 100. P1 is the proportion of students who did their homework. N2 is 200 people in the school 2 and 0.50 for the proportion. So N1 times P1 is 100 times 0.7, which is 70. That's good. N2 P2 would be 200 times 0.5, which is going to get 100. That works. N1, 1 minus P1 100 times the opposite of 70 would be 30. And we get 30 is greater than, that works. And 2 is 200 times 0.5. We're going to get the same answer as the last one, 110. Check mark. So this is approximately normal, the shape, because of that work. What's the center? We tell the center from typically the mean. So the mean of one, the mean of the other, or the proportion of one and the other, your center is going to be 0.20. Standard deviation is kind of the trickiest one, and that's where we're going to be required to do that big formula that we were just talking about. P1 is the 70, and then you need the opposite, which is 30, 100. And this is 0.5 and 0.5 of 200. So I think we've got 0.0021 and 0.00125, if I remember correctly. And combined, it's 335. And square rooted is, where's my work here? 0.057879. And that would be my spread, or my standard deviation. Probability of getting a 0.10 or less. Think of probability. How would I get here or less? I need to find a score here, a z-score. And you can think about what numbers you would use. What did they measure? And what are we supposed to get, our expected value? And the standard deviation should be underneath. So I believe I'm getting a negative for this one. Actually, I'm going to put negative 1.73. And then you need to use your table, 0418. So if our probability is 0.04, is it likely to happen? And we've talked about this before, that P is low. We don't think that this is something that would normally happen, or a proportion is low. So this isn't really a stats test or a significance test where you have the P is low and you have the alpha, but the probability is really about 4%. So I would say something like there is only a 4% chance of getting a difference of let's say, getting a difference, I'm going to back it up for a second, in sample proportion. We forgot to put that in. As small or even smaller than 0.10, which is reported by the counselors. Something you should say something like, this is unlikely to happen, or this is suspicious.